Hey guys, tonight we're going to take a journey through one of the most incredible wonders of our universe, Andromeda. But first, let's just pause and take a moment to think about the night sky. Imagine you're lying on your back, your eyes squinting just slightly as you gaze up into the dark expanse above. It's a cool evening, the air's soft and still. The stars are scattered like diamonds, each twinkling in the vast, velvety black. And somewhere, not far from that sparkling sea of stars, lies Andromeda. It's a faint smudge in the sky, a soft blur, almost imperceptible if you're not paying attention. You can barely see it with the naked eye, just a dim, ghostly smear of light among the countless stars. And yet, that smudge, that blur, is something extraordinary. It's our closest galactic neighbor, a massive spiral galaxy, and it's about 2.5 million light-years away. In the grand scale of the universe, that's just a stone's throw away. Andromeda is like a faint memory of the past, its light traveling all this way, reaching us with a story that's millions of years old. Imagine, the light you're seeing now actually left Andromeda long before human civilization even existed. It's a distant whisper from the past, and yet here we are, connecting with it across the eons. Andromeda has been with us since we first looked up at the sky. It's been here for thousands of years, noticed by the ancient stargazers, yet always a mystery, just beyond the reach of full understanding. And now, with the help of powerful telescopes and instruments, we can begin to uncover its secrets. But before we dive into the complexity of Andromeda's structure and history, let's keep in mind that it all starts with that smudge in the sky. It's a reminder of how vast the universe is and how much we still have yet to uncover. That faint smear is a galaxy, an entire system of stars, gas, dust, and dark matter all held together by gravity, dancing through space. It's the story of stars being born and dying, of cosmic forces shaping it over billions of years. And for us, it's one of the most immediate connections to the infinite beyond. For a galaxy so far away, Andromeda carries with it a deep sense of intimacy. You might not be able to make out the details from your vantage point here on Earth, but its presence is undeniable, like a distant relative you've never met but somehow feel tied to. And tonight, as we explore it together, we'll pull back the curtain and see more than just the blurry outline. We'll uncover the truth behind that smear, the galaxy itself, and the forces at play in its never-ending dance through the cosmos. Now, before you get too comfortable, take a moment to like the video and subscribe, but only if you genuinely enjoy what I do here. Let me know where you're tuning in from and what time it is where you are. I'd love to hear from you. Now, dim the lights, maybe turn on a fan for that soft background hum, and let's ease into tonight's journey together. As we venture deeper into the heart of Andromeda, we start by acknowledging that its immensity is not something you can fully grasp at first glance. The size of Andromeda is so vast that, even with the most advanced instruments, we still struggle to capture it in all its glory. The galaxy's spiral arms, rich with the light of stars, dust, and gas, stretch far and wide. And yet, it's not just the stars that make up Andromeda. There's much more lurking beneath the surface, far beyond what can be seen with the naked eye. It's almost like looking at the tip of an iceberg. What we see is just a tiny fraction of what's truly there. The galaxy's stars, though bright and captivating, are only the beginning. Andromeda's full story lies in the invisible, in the dark matter that binds it together, in the gas clouds that fuel its star formation, and in the dust that weaves through its arms. These hidden elements shape not just the galaxy's structure, but its very existence. Without them, there would be no Andromeda. The stars would be scattered, the gas clouds would dissipate, and the spiral arms would disintegrate. The reality of Andromeda's size and power can't be fully appreciated until we step back and see it for what it is, a massive, dynamic system, one that has been evolving for billions of years. And the journey of understanding Andromeda is one that reveals the delicate balance of forces at work: gravity, dark matter, and the birth and death of stars. These forces are what give Andromeda its shape, its beauty, and its incredible energy. And even though the galaxy seems still and serene from where we stand, it's anything but quiet. It's constantly changing, constantly alive, constantly growing. This is the true magic of Andromeda. Its subtlety, its mystery, and its power. The fact that it's so far away, yet still so present, is a testament to the vastness of our universe. And tonight, we'll unravel the layers of this cosmic giant, starting with that faint smudge and eventually revealing the immense, living galaxy that lies just beyond our reach. So let's keep going, step by step, and uncover the secrets of Andromeda, piece by piece. As we float further along on our cosmic journey tonight, imagine yourself now shifting your gaze from the outer spiral arms of Andromeda, that faint smear of light, to the unseen heart at its core. We often marvel at the outer beauty of galaxies, their sprawling arms and glowing stars. But what lies beneath the surface, hidden from the naked eye, is equally extraordinary, perhaps even more so. In Andromeda, this hidden structure is where things get truly fascinating and where a sense of mystery looms large. The center of Andromeda, just like in our own Milky Way, harbors an unseen force, a dark and massive entity, responsible for much of the galaxy's behavior. It's not a single star or a cluster of stars that defines this core. Instead, it's a supermassive black hole, a dark, dense region in space where gravity is so intense that not even light can escape. Imagine, deep at the center of Andromeda, gravity is pulling everything inward, stars, gas, dust, all tumbling into the invisible abyss. This black hole is far from the void we might expect. In fact, it's more like a cosmic engine, powering the galaxy's core. Its mass is enormous, millions of times greater than the Sun, and it's the gravitational anchor that keeps the galaxy spinning in place. The stars near the center of Andromeda orbit this black hole in such a way that astronomers can measure the black hole's presence without seeing it directly. It's like watching the movement of the water in a pool without seeing the current. It's the invisible force that shapes everything. This supermassive black hole is not some theoretical idea, but a proven reality. Through the careful study of star orbits and the motion of gas clouds around Andromeda's center, astronomers have been able to pinpoint the location and mass of this behemoth. And even though we can't see the black hole itself, because light can't escape it, its influence is undeniable. It's as if the galaxy is held together by a cosmic anchor, unseen but omnipresent. This is the heart of Andromeda, and it's alive in a way that you might not expect. The fact that black holes remain hidden in plain sight doesn't make them any less awe-inspiring. These objects are not just a void. They're some of the most dynamic entities in the universe. At their core, black holes represent the extreme, where the laws of physics break down, where matter is crushed into an infinitely small point, a singularity where space and time themselves are warped. But in the case of Andromeda's black hole, there's more to the story than just this invisible mass. As it pulls in matter from its surroundings, the material gets heated to extreme temperatures, and that energy is emitted in various forms, including X-rays. These emissions are some of the first clues we have that a supermassive black hole exists in a galaxy's center, and they help astronomers detect them from billions of light years away. If you were able to somehow hover above Andromeda's core, it would be an eerie scene. Around the black hole, the gas and dust would be swirling, spiraling toward the event horizon, the boundary from which nothing can return. It would look like a whirlpool in space, a violent cosmic maelstrom, but it's a quiet one, silent, slow, and vast. Despite the chaos near the black hole, the rest of the galaxy appears tranquil from the outside, spinning in graceful arcs. This juxtaposition between the calm arms of Andromeda and the violent core, where everything is pulled into the black hole, gives the galaxy a sense of living, breathing complexity. It's a galaxy with a hidden pulse, and that pulse is driven by its supermassive black hole. Now, I know what you might be thinking. What exactly happens at the very heart of these black holes? What lies inside? Well, that's the big question. Since we can't travel there, we can't know for sure. All we have are the clues. The movements of stars, the emissions of high-energy radiation, and the overall dynamics of the galaxy center. Some theories suggest that the supermassive black hole might be a remnant of the early universe, growing larger and larger by pulling in material from the galaxy and perhaps even merging with other smaller black holes over time. Andromeda, with its dark heart, is a prime example of how galaxies evolve, with the black hole at its center playing a pivotal role in shaping its structure and future. There's a kind of eerie beauty in the idea that the heart of Andromeda is invisible to our eyes, yet influences everything around it. The black hole doesn't just sit there, static in the center. It's constantly feeding, slowly pulling in gas, stars, and other matter, reshaping the galaxy as it does. The galaxies themselves, like Andromeda, seem to be alive in a way we don't always acknowledge. They grow, they change, and they feed on themselves, just like we do. The idea that a galaxy can be so driven by something so invisible and mysterious is almost poetic. It's a reminder that the cosmos is full of hidden forces, things we can't see, but feel the effects of nonetheless. Andromeda's heart is more than just an astronomical curiosity. It's a mirror, reflecting the hidden dynamics of our own Milky Way. Our galaxy, too, harbors a similar beast at its center, the supermassive black hole known as Sagittarius A*, and just like Andromeda, it governs the motions of stars and gas around it. Understanding Andromeda's black hole is not only about understanding one galaxy. It's a key to unlocking the secrets of how galaxies like our own evolve, grow, and eventually collide. But the mystery doesn't end there. For all the study we've done on these colossal black holes, the true nature of their behavior remains elusive. How do they grow so large? How much of a role do they play in the galaxy's overall structure and evolution? What is the fate of the gas and matter that gets sucked into them? We may never have all the answers, but the exploration continues. And Andromeda, with its dark, unseen heart, stands as one of the most fascinating examples of what lies hidden just beneath the surface of galaxies. As we continue our journey through the intricate beauty of Andromeda, let's turn our attention now to a quieter, yet no less essential, aspect of the galaxy, the birth of stars. Picture yourself soaring above the glowing spiral arms of Andromeda, sweeping through cosmic clouds of gas and dust, where the very essence of life itself is being forged. In this space, millions of stars are being born, but unlike the fiery giants you may have seen in your mind's eye, their birth is a quiet, often hidden process, one that takes place in the cool darkness of stellar nurseries. Stars aren't born overnight. It's a slow and turbulent process, one that begins with the collapse of vast clouds of gas and dust, primarily composed of hydrogen. The journey of star formation starts when these gas clouds, often hundreds of light years across, become unstable due to some disturbance. A nearby supernova, the shock wave from passing star, or even the gravitational pull from another cloud can trigger the collapse. Once that happens, gravity takes over. Slowly, inexorably, the cloud begins to collapse in on itself, its material drawn toward the center where pressure and temperature rise. This collapsing gas cloud, known as a molecular cloud or a stellar nursery, begins to heat up as its particles collide with one another. As the core of the cloud becomes increasingly dense and hot, nuclear fusion is triggered. The first faint glimmer of a new star appears. This star is still in its infancy, much too hot and bright for us to see clearly at first, but its presence is undeniable. It's like a flickering ember, a promise of new life in the galaxy. In Andromeda, these stellar nurseries are scattered throughout the spiral arms, regions where the material of the galaxy is most concentrated. If you were to look at them through a telescope sensitive to infrared light, the view would be stunning. Vast clouds of gas and dust glowing faintly, revealing the very process of creation. These clouds, once invisible in the visible spectrum, now shine with the birth of countless new stars. But it's not just the stars themselves that we see. It's the entire ecosystem of material, the gas, dust, and light that interacts to create something new. Every glowing patch of light you see is part of the larger, never-ending cycle of cosmic renewal. The process of star formation is a complex one, involving not just the birth of the stars themselves, but the entire environment around them. Once the star is born, it begins to emit light and radiation, pushing away the remaining gas and dust in its immediate vicinity. This is when the star enters what is called the main sequence phase of its life, where it will spend the majority of its existence, fusing hydrogen into helium in its core. But even as a young star settles into its role, the surrounding region is still alive with activity. The star may be illuminating nearby gas clouds, causing further star formation, or it could be blowing away material, sculpting the surrounding space into beautiful nebulae. What's particularly fascinating is how this process unfolds over time. These stellar nurseries are not static. They evolve, sometimes slowly and sometimes rapidly, as new stars continue to form, grow, and eventually die. When stars reach the end of their lives, their deaths contribute to the cycle of star formation in a different way. A dying star, particularly one that explodes in a supernova, releases a vast amount of material back into space, enriching the surrounding gas clouds with heavier elements. These elements, carbon, oxygen, nitrogen, are the building blocks for new stars and planets, continuing the cycle of birth, death, and rebirth in the galaxy. In Andromeda, these regions of active star formation are critical to the overall evolution of the galaxy. They're the places where new stars, planets, and potentially life could form in the future. The stars that are born in these nurseries will go on to shape the galaxy in ways we're only beginning to understand. Some may live out their lives in the heart of Andromeda, their light illuminating the surrounding space for billions of years. Others will be flung into the galaxy's outer reaches, where they may one day collide with other stars or galaxies, sparking new waves of creation. And in a way, the galaxy is constantly being reborn. The stars that are born today will eventually die, their material reabsorbed by the galaxy to fuel the next generation of stars. And Andromeda, a living, breathing entity, continues to cycle through this endless process, its arms full of potential and promise. As we move through this star-making region, it's important to remember that not all stars are created equally. Some are massive, burning hot and fast, their lives lasting only a few million years. Others are smaller, cooler, and more stable, living for billions of years. The mass of a star plays a huge role in determining its fate. Larger stars burn through their fuel much more quickly, ending their lives in brilliant supernovae. Smaller stars, however, can burn more slowly, living out a peaceful existence until they eventually become white dwarfs. But no matter their size, all of these stars contribute to the larger picture of Andromeda's evolution. Some will go on to form planetary systems, while others will remain solitary, their light still bright in the cosmic sea. These stars are the building blocks of the galaxy, and each one plays its part in shaping the future of Andromeda. What's especially remarkable about star formation in Andromeda is that it's not a singular event. It's a process that has been going on for billions of years, and it will continue long into the future. The galaxy is alive with the energy of creation, constantly reshaping itself as new stars are born and old ones die. As we look at Andromeda, we're not just seeing a galaxy in its current state, we're seeing a snapshot of a never-ending process, a glimpse into the very fabric of the universe itself. Imagine, if you will, a cosmic orchestra in which each star is an instrument, each gas cloud is a note, and the entire galaxy is the music. The sound may be imperceptible to our ears, but the rhythm is undeniable. It's a rhythm of creation, destruction, and rebirth, a dance that plays out on a scale far beyond our comprehension. And as we watch from afar, we're not just observers. We are part of the music, a small but significant piece in the greater symphony of the cosmos. When we look up at Andromeda, we see more than just a collection of stars. We see the story of life itself, constantly unfolding, constantly changing. And in that story, there's a place for us too. The elements that make up our bodies were forged in the hearts of stars, just like those in Andromeda. And the processes that are happening in this distant galaxy are the same ones that shape the Earth, the Sun, and the very fabric of our existence. In the end, the story of star formation in Andromeda is the story of all galaxies, of all life. It's a story of birth, of growth, and of eventual transformation. It's a story that will continue long after we've moved on, a story that reminds us of our place in the universe, and of the amazing processes that are still at work, shaping the stars and planets, the galaxies, and the cosmos itself. We've spent some time marveling at the birth of stars, but it's time to take a step back and rethink our view of Andromeda, and indeed, all galaxies, because there's so much more than just the brilliant clusters of stars that catch our eye. While stars are undoubtedly the shining jewels of any galaxy, galaxies themselves are vast, complex ecosystems, woven together from much more than just the glowing balls of gas and heat that we think of as stars. As we move deeper into Andromeda, we begin to see that the galaxy's true nature is shaped by a much broader and more intricate web of forces. The stars may be the brightest members of the family, but they are far from the whole story. One of the key components of Andromeda's structure that often goes unnoticed by the casual observer is the vast network of gas and dust that permeates the galaxy. If you've ever looked up at the night sky and noticed the milky smudge of the Milky Way, you've seen the raw materials that make up the cosmic web of a galaxy. Andromeda, despite its name, is not just a collection of stars. It's a sprawling system that includes enormous gas clouds, dust lanes, and immense forces of gravity that dictate how stars are born, live, and die. Imagine the galaxy as an artist's canvas, and the stars are just the final strokes, the bright points of light. The gas and dust that fills the space between them are the paint, the medium in which the artwork comes to life. This gas and dust are far more than decorative. They're the building blocks of everything we see, the very stuff of the universe. These clouds of gas are the raw material from which new stars are formed, as we've already discussed. But they also serve as the material that nourishes and sustains older stars, the remnants of which add their own contributions to the galaxy. These clouds of gas, filled with hydrogen and helium, can extend vast distances, hundreds of thousands of light years, and within them, stars are born, burn bright, and eventually die, returning their material to the cloud to start the cycle over again. This continual exchange is the life cycle of a galaxy. As we float farther out from the core of Andromeda, we see not only gas, but also dust. This cosmic dust might seem inconsequential, but in fact, it plays a crucial role in the evolution of the galaxy. In the same way that dust in a dusty room can obscure your vision, the dust in Andromeda clouds our ability to see stars directly. It blocks some of the light from the stars behind it, creating those familiar dark lanes that stretch across the spiral arms. But instead of hiding all the beauty of the galaxy, it reveals something far more profound: the complexity and interconnectedness of the galaxy's structure. In fact, this dust is so important that it shapes the very appearance of Andromeda. The dust absorbs light from stars and scatters it, creating a complex interplay of shadow and illumination that we observe in the galaxy's arms. In many ways, the dust and gas give Andromeda its character, its beauty, its complexity. Without them, the galaxy would be a much more mundane, ordinary collection of stars, a faint blur in the sky. But the presence of this dust, scattered across the galaxy, is what gives Andromeda its iconic spiral shape and gives each arm its own distinct look. The contrast between the dark, dusty lanes and the bright, glowing clusters of stars is what makes Andromeda stand out in the night sky. What makes it so captivating to our eyes? We might think of galaxies like Andromeda as being primarily composed of stars, but in reality, their structure is determined by the gravitational pull of gas, dust, and dark matter. The stars are merely the points of light, the visible manifestations of much deeper, hidden processes. The motion of these invisible elements, the gas, the dust, the dark matter, is what shapes the spiral arms of the galaxy, what draws the stars into orbit, and what binds the entire galaxy together. It's as if the stars are just the surface of a much deeper and more intricate fabric, one that holds the galaxy together and allows it to evolve. The presence of dark matter, for example, is crucial in understanding how galaxies like Andromeda maintain their shape. While we can't see dark matter directly, we know it exists because of its gravitational influence on the visible matter in the galaxy. Dark matter acts as an invisible scaffolding, a cosmic framework that keeps the galaxy's stars in place, allowing them to move through space in an orderly fashion. Without dark matter, Andromeda would not be the majestic spiral we know. The stars would simply fly off into space, and the galaxy would lose its cohesion. The gas, dust, and dark matter work together to keep Andromeda in balance, to maintain its delicate equilibrium as it spins through the cosmos. This cosmic dance is a slow one, unfolding over billions of years. And as we look at Andromeda, we're not just looking at a collection of stars. We are looking at the interplay of countless elements: the visible stars, the invisible dark matter, the gas, the dust, that are all working together to create a living, breathing galaxy. And within this vast system, stars are born, die, and are reborn, forming a never-ending cycle that shapes the future of Andromeda. It's easy to focus on the stars, to be mesmerized by their brilliance. But if we look deeper, we see the full complexity of Andromeda. This is what makes the galaxy so much more than just a patch of light in the night sky. It's a dynamic, living system, one that is always changing, always evolving, and always creating. The stars, the gas, the dust, and the dark matter are all part of a grand cosmic ballet, each element contributing to the whole. Without one, the entire structure would collapse. So, as we continue our journey through Andromeda, remember that this galaxy is not just a collection of twinkling stars. It's a complex, intricate system, a tapestry woven from countless threads. Each star, each cloud of gas, each speck of dust plays its part in the galaxy's ongoing story. It's a story that has been unfolding for billions of years, and one that will continue to unfold for billions more. What makes Andromeda truly spectacular is not just the stars we see, but the invisible forces and materials that shape the galaxy. These are the unseen architects of the galaxy, working behind the scenes to create the stunning, majestic system that we observe. And it's a reminder that sometimes the most important elements in the universe are those we can't see, whether it's the dust, the gas, or the mysterious dark matter. These hidden forces are what allow galaxies to thrive and evolve. They're the true building blocks of the cosmos. When we look up at Andromeda, we often find ourselves captivated by the brilliance of its stars, the way they twinkle in the night sky. But what if I told you that those stars, brilliant as they may be, are part of a much larger, infinitely more complex cycle? A cycle that spans billions of years, one that sees stars being born, living out their brief, fiery existences, and ultimately dying in a cosmic blaze. The stars we see in Andromeda are not eternal. They're simply the latest generation in a long line of celestial births and deaths, an ongoing process that shapes the very heart of the galaxy. The life of a star begins with gas. A cloud of gas and dust, often a few million times the mass of our sun, floats in space. It's cold and diffuse, but like a seed, it holds the potential for something much more dramatic. As this gas cloud collapses under its own gravity, the pressure and temperature at its core rise to unimaginable levels. Eventually, nuclear fusion ignites, and a new star is born. This process, called stellar birth, marks the beginning of a star's life. From that moment on, the star will burn bright, fusing hydrogen into helium and releasing enormous amounts of energy. Stars live for millions, sometimes billions of years, depending on their size. The larger the star, the shorter its life. Massive stars burn through their fuel at a furious rate, rapidly fusing elements and creating ever heavier elements in the process. But eventually, every star runs out of fuel. When this happens, the star begins to die. The death of a star is often as dramatic as its birth, and sometimes even more so. The core of the star contracts, while its outer layers expand, sometimes turning into a supergiant. Eventually, the star can no longer hold its massive structure together. It explodes in a brilliant supernova, scattering its outer layers across space, enriching the surrounding gas clouds with heavier elements like carbon, oxygen, and iron, materials that will go on to form new stars, planets, and even life. But not all stars die in a supernova. Some, particularly stars with smaller masses like our Sun, end their lives quietly. They expel their outer layers, creating a beautiful nebula, leaving behind a dense, hot core known as a white dwarf. Over time, this white dwarf cools, fading away into the cold darkness of space. The death of a star, however it occurs, is never truly the end. It is simply the beginning of something new. When a star dies, it doesn't just vanish. It leaves behind the very building blocks for future generations of stars, planets, and life itself. In Andromeda, this cycle is happening constantly, over and over again. Stellar nurseries, regions where stars are born. The galaxies' spiral arms. These nurseries are vast clouds of gas and dust, places where new stars ignite and begin their life cycles. In these regions, the birth of stars is often triggered by the shock waves from nearby supernovae, which compress the gas clouds and kickstart the process of star formation. It's a beautiful dance. One generation of stars ignites, burns, and dies, enriching the galaxy with the materials necessary for the next. As the stars age and die, their remains, especially those from supernovae, become an essential part of the galaxy's evolution. These remnants contribute to the gas and dust clouds that will eventually form new stars. They provide the raw materials, like carbon and oxygen, that are essential for life. The cycle of stellar birth and death is the engine that drives the evolution of galaxies, including Andromeda. The gas that fuels this cycle doesn't just come from nowhere. It's recycled, an endless process of creation and destruction that keeps the galaxy dynamic. As stars die and explode, they release vast amounts of gas and dust back into space. This material then becomes part of the interstellar medium, a vast ocean of gas and dust that floats throughout the galaxy. Over time, gravity causes this material to clump together, forming new clouds of gas. These clouds, once they become dense enough, collapse under their own weight, triggering the birth of new stars. It's a beautiful, never-ending cycle that makes galaxies like Andromeda so dynamic and alive. But not all stars die in the same way. The fate of a star depends on its mass. The most massive stars end their lives in a dramatic supernova explosion, while smaller stars, like our Sun, gently fade away into white dwarfs. These deaths have different consequences for the galaxy. Supernovae, for example, can trigger new waves of star formation by sending shock waves through the surrounding gas clouds. This is why regions of Andromeda with a high concentration of supernovae often also have high rates of star formation. The death of one generation of stars creates the conditions necessary for the birth of the next. Supernovae are particularly important because they're the primary source of the heavy elements that make up the universe as we know it. When a star explodes in a supernova, it creates elements like iron, nickel, and gold. These elements are then scattered across space, where they eventually become part of new stars, planets, and asteroids. Without these explosions, the universe would be a very different place. In Andromeda, the remnants of these explosions can be seen in the form of supernova remnants, glowing clouds of gas and dust that mark the death of massive stars. As we gaze at the spiral arms of Andromeda, we're looking at the remnants of these processes, at the stars that were born, lived, and died in this galaxy. The bright clusters of stars that we see are often the newest generation, still shining brightly after only a few million years of life. The older stars, the ones that have already gone through their cycles of birth and death, are scattered throughout the galaxy, their remnants enriching the gas clouds that give rise to new stars. But this process is far from static. It's an ongoing cycle of life, death, and rebirth that shapes the galaxy. And Andromeda, as massive as it is, will eventually run out of the material necessary to create new stars. This won't happen for billions of years, but it's something that will eventually occur. When that happens, Andromeda will become a quieter galaxy, one where fewer new stars are born, and the ones that remain slowly fade away. But for now, Andromeda is alive with the birth and death of stars, each generation contributing to the overall structure and evolution of the galaxy. To truly understand Andromeda, we need to look beyond the glittering stars that its arms and focus on the invisible structures that are just as integral to the galaxy's formation and function. Among these hidden elements, gas and dark matter play crucial roles in shaping the galaxy's present and future. But these are not the kinds of things you can simply see with your eyes, and certainly not with any ordinary telescope. No, understanding the full scope of Andromeda requires a far more intricate and scientific approach, one that allows astronomers to peer into the hidden corners of the galaxy, tracking the gas that is continually being recycled and the dark matter that influences its every movement. One of the most fascinating tools that scientists have developed to explore Andromeda is the use of radio telescopes. These specialized instruments allow us to detect the faint emissions produced by neutral hydrogen atoms in the galaxy. These hydrogen atoms emit a specific frequency of radio waves, 21 centimeters in wavelength, providing astronomers with a means to map out how gas is moving through the galaxy. But more than that, the radio emissions from hydrogen allow us to see not only how gas flows within Andromeda, but how it behaves within the larger cosmic structure. By tracking the movement of hydrogen gas, scientists can build up a picture of Andromeda's spiral structure, its arms, its core, and its halo. The movements of these gas clouds reveal much more than simply where gas is. They also show how the gas is interacting with other components of the galaxy. In some areas, the gas clouds are tightly packed, likely forming new stars. In other regions, the gas moves in more diffuse ways, suggesting areas where star formation may not be as active, or where older stars are past their prime and no longer enriching the surrounding gas. This gas isn't just in the visible parts of the galaxy, either. If we focus on Andromeda's outer regions, we start to encounter a truly strange phenomenon: dark matter. While dark matter can't be seen directly with any telescope, its presence is revealed through its gravitational effects. Gas clouds orbiting the galaxy at extremely high speeds provide indirect evidence of dark matter's existence. The gas's rapid rotation cannot be explained by the visible mass of stars alone. Something else must be there, something that doesn't emit light or radiation. That something is dark matter. Dark matter is one of the great mysteries of modern astronomy. It makes up about 27% of the universe's total mass energy content, yet we have no idea what it actually is. It doesn't interact with light, which is why we can't see it, but we can feel its effects. In Andromeda, the presence of dark matter affects the motion of stars and gas, keeping the galaxy from flying apart. Without dark matter, galaxies would not have the necessary gravitational pull to hold themselves together, and their structure would dissolve over time. The fact that we can track the movement of gas in Andromeda and use that information to infer the presence of dark matter is a testament to just how much of the universe is still hidden from our understanding. As we dig deeper into the role of gas and dark matter, we also uncover something surprising about Andromeda. It doesn't just hold gas within its spiral arms and core. It is surrounded by a vast halo of gas and dark matter, extending far beyond what we can see with our eyes. This halo plays a major role in the galaxy's overall structure, anchoring the galaxy's spiral arms and holding the galaxy's gas in place. Without this halo, Andromeda would be a far less stable system, and its spiral shape might collapse into something far more chaotic. Astronomers have used a variety of instruments to map out the distribution of gas and dark matter in Andromeda, each one revealing different aspects of the galaxy's hidden infrastructure. In addition to radio telescopes, which give us insight into the gas, X-ray telescopes provide a different perspective, highlighting the hot, energetic regions of the galaxy. These X-rays often come from the remnants of supernova explosions or from hot gas falling into the galaxy's central black hole, which we'll explore in more detail later. The combination of these different observational techniques allows scientists to piece together a more complete picture of Andromeda, one that goes far beyond what we can see with visible light. Andromeda's gas is not just static, either. It's constantly in motion, flowing through the galaxy in a way that mirrors the movement of stars. In some regions, gas is moving toward the galaxy's core, where it may eventually collapse and form new stars. In other areas, gas is being pushed outward, carried by the galaxy's rotation or by interactions with nearby galaxies. The motion of this gas can be mapped through a variety of means, including the Doppler shift of light emitted by the gas. By measuring how the gas shifts in wavelength as it moves toward or away from us, astronomers can determine the gas's velocity and direction. This motion, this dance of gas through Andromeda, is just one part of the galaxy's ongoing life cycle. The gas that is currently being mapped and studied will eventually collapse under its own gravity, forming new stars. And when those stars die, they will return their material to the gas clouds, where it will be recycled once again. This process of gas flowing, collapsing, and forming stars is what keeps galaxies like Andromeda alive, constantly in flux, constantly evolving. As we map the gas and dark matter in Andromeda, we're also learning more about how galaxies interact with each other. Andromeda, while vast in its own right, is not alone in the cosmos. It is part of a cosmic neighborhood known as the Local Group, which includes our own Milky Way, the Triangulum Galaxy, and a number of smaller galaxies. The interactions between these galaxies play a crucial role in shaping the way gas flows within them. Gravitational interactions between Andromeda and its neighbors can cause gas to flow between galaxies, triggering waves of star formation in the process. In fact, some of the gas clouds we observe in Andromeda may have originated in other galaxies, transferred through the gravitational pull of Andromeda itself. The galaxy's future, then, is bound up not only in its internal dynamics, but also in its interactions with other galaxies. While Andromeda's core and spiral arms are relatively stable, the galaxy's outer regions, especially its gas clouds and dark matter halo, are constantly shifting, interacting, and evolving. These interactions will shape the galaxy for billions of years to come. By studying Andromeda's gas and dark matter, we gain valuable insights not only into the workings of this particular galaxy, but into the broader processes that govern galaxy formation and evolution. We learn about the cycles of birth and death, the flow of gas, and the ways that galaxies interact with each other. But we also learn something much deeper. We learn about the unseen forces that hold galaxies together, forces that we can't see directly, but that we know must be there because of their effects on the universe around us. In Andromeda, as in the rest of the universe, there is much that remains hidden, much that we can't perceive with our eyes or even with our most advanced instruments. But the more we study, the more we begin to see the patterns, the invisible structures, the underlying forces that shape the universe. And in those discoveries, we come ever closer to understanding the universe as a whole, its gas, its dark matter, and the extraordinary dance of galaxies. Andromeda, our distant cosmic neighbor, has captivated human imagination for millennia. But for all its grandeur, it is a galaxy of complexity far beyond what the naked eye can capture. Its spiral arms, its clusters of stars, its gas and dust clouds, they are all interwoven in a delicate balance of cosmic activity. To truly understand Andromeda, we have to look beyond the visible, diving into the realms of light that go unseen by our eyes. This is where the magic of modern astronomy comes into play, as we turn to wavelengths that are invisible to us: infrared, ultraviolet, and X-rays. Each of these allows us to unveil a different layer of Andromeda's hidden world. Visible light, the spectrum our eyes are tuned to, only reveals part of the story. When we look at Andromeda through a typical telescope, we see a blur of stars, dust, and gas, its spiral shape faintly outlined against the dark sky. The galaxy presents itself as a glowing smear, a beacon of light from billions of stars. But that image is incomplete. The true Andromeda, with all its intricacies and hidden components, can only be fully appreciated through the power of specialized telescopes that allow us to peer into the universe's many unseen corners. One of the most revealing perspectives comes from infrared observations. When we observe Andromeda in infrared light, we are able to see what is otherwise hidden beneath the dust clouds that obstruct our view in the visible spectrum. Dust and gas are common in any galaxy, but in Andromeda, these elements take on new significance. Dust, far from being just a nuisance, is actually the birthplace of stars. In the infrared, this dusty veil that obscures so much of the galaxy's core reveals itself. We see not just the stars that light up the arms of Andromeda, but the dense clouds of gas and dust that are the stellar nurseries, where new stars are born. These nurseries are the lungs of the galaxy, as astronomers like to say. Within them, the cold gas and dust come together, forming the building blocks of new stars. And in the infrared, the young stars glow with a heat that makes them visible even when they are hidden behind the obscuring dust. These glowing regions are scattered throughout Andromeda, marking areas of intense activity. We begin to see the true life of the galaxy in these warm, glowing pockets, areas of star formation that are otherwise invisible to our eyes. If infrared gives us a glimpse into the stellar birthplaces, ultraviolet light reveals the fiery youth of the galaxy. Ultraviolet light is emitted by the hottest, most massive stars, those that are in their prime, burning hot and bright. These stars are the powerhouses of Andromeda, contributing to the galaxy's overall luminosity. The ultraviolet view of Andromeda uncovers regions of intense star formation. These young, massive stars burn hot, radiating ultraviolet light, which gives us clues about the ongoing processes in the galaxy's spiral arms. Ultraviolet observations also help us trace the location of Andromeda's most recent star formation, pinpointing areas where stars have just been born and where they are still active. But ultraviolet and infrared observations alone don't give us the full picture. The most dramatic and energetic aspects of Andromeda's life can only be seen in X-ray light. X-rays are produced by the hottest and most violent phenomena in the galaxy: supernova remnants, black holes, and the heated gas around them. At the center of Andromeda lies a supermassive black hole, and while it cannot be seen directly, the surrounding area, where gas is spiraling inward, glows with intense X-ray emissions as it is heated to millions of degrees. These X-rays are a product of the extreme forces at play, and they give us valuable insights into the dynamics of Andromeda's heart. In fact, X-ray observations reveal some of the most energetic processes in the galaxy. We see the aftermath of stellar explosions, the remnants of supernovae that have flung their material into space. These X-ray emissions tell the story of stellar death, the explosive ends of stars that were once the core of the galaxy's star-forming activity. The X-ray view of Andromeda is like a snapshot of its violent side, a record of the intense forces at work in its center and throughout its spiral arms. But we don't just look at one wavelength of light at a time. Astronomers have the ability to combine all of these different types of data, infrared, ultraviolet, and X-rays, into one cohesive image, creating a picture of Andromeda that is richer and more detailed than ever before. Each wavelength contributes its own piece to the puzzle. The infrared reveals the gas and dust where stars are born. The ultraviolet highlights the bright young stars that fill the galaxy's arms. And the X-rays give us a look at the energetic explosions and the violent forces at play near the supermassive black hole at the galaxy's core. These combined images form a kind of cosmic tapestry, woven together from different layers of Andromeda's life. With the ability to observe the galaxy in this multi-wavelength manner, astronomers can build a much more complete picture of how Andromeda works. They can see where stars are forming, where they are dying, and how the galaxy's dynamic processes, like gas inflow, star birth, and black hole activity, are interconnected. These observations, across different wavelengths, allow scientists to track Andromeda's ongoing evolution, helping them understand not just where the galaxy is now, but where it will be in the future. Even with all the powerful telescopes and instruments at our disposal, there are still elements of Andromeda that remain elusive. Some parts of the galaxy are so far away or so hidden behind dense clouds of gas and dust that we can't see them clearly, even in infrared. And some areas are so faint that they don't register on our most sensitive detectors. But with each new technological advance, we're getting closer. The launch of more advanced space telescopes, like the James Webb Space Telescope, promises to open up even more mysteries of Andromeda, allowing us to peer even deeper into the galaxy's hidden recesses. Each new generation of instruments brings us closer to understanding the full complexity of this magnificent galaxy, piece by piece, layer by layer. In this way, Andromeda's secrets are being slowly but surely uncovered. And what we are learning through infrared, ultraviolet, X-rays, and beyond is that Andromeda is far more than the distant smear of light we first saw through our telescopes. It is a living, breathing, ever-changing galaxy full of hidden treasures waiting to be discovered. Through the lens of these different wavelengths, we begin to see Andromeda not as a distant, incomprehensible blur in the sky, but as a dynamic, vibrant system, a system in the midst of an ongoing process of birth, death, and renewal. And each new piece of the puzzle helps us understand not only Andromeda itself, but the very nature of galaxies across the universe. As we continue our journey through Andromeda, we encounter a vital aspect of its cosmic life that might not be immediately visible: its gas. You might picture galaxies as just clusters of stars, but this is only a fraction of the picture. There's something just as fundamental to Andromeda's existence: gas. This invisible material is the lifeblood of the galaxy, constantly flowing, collapsing, and forming new stars. Just like how we breathe, galaxies breathe too, through their gas. But in Andromeda's case, this process is far more complex than the gentle rise and fall of human breath. It is a cosmic cycle that keeps the galaxy alive and evolving, constantly changing as the gas moves through its spiral arms. Imagine Andromeda as a vast system of swirling gases, stretching across millions of light years, constantly reshaping itself. The galaxy inhales gas from the vast intergalactic medium and exhales the same material after it's been processed, forming stars, enriching the interstellar medium, and recycling material over cosmic timescales. This ongoing cycle of gas movement and transformation keeps Andromeda alive. Without this breathing, the galaxy would stagnate. No new stars would form, and eventually, the existing stars would die out, leaving behind a dark and empty galaxy. But this is not Andromeda's fate. It continues to breathe, continually replenishing itself, sustaining its population of stars. The mechanism that drives this breathing is the collapse of gas clouds under the force of gravity. In the densest regions of the galaxy, gas clouds begin to condense, drawn together by the force of gravity, creating stellar nurseries, regions of the galaxy where new stars are born. As these gas clouds collapse, they heat up, triggering nuclear fusion at the core of these new stars. This fusion process releases vast amounts of energy, lighting up the surrounding gas, giving birth to new generations of stars. And this process is not limited to just the spiral arms of Andromeda. It happens everywhere, across the galaxy, in the dark recesses of the interstellar medium, where gas clouds are constantly undergoing this transformation. At the same time, gas doesn't just sit still. It moves throughout Andromeda, swirling in the galaxy's spiral arms, pulled by the forces of gravity. It's not just the stars that shape the galaxy's structure. Gas plays a huge role in the formation and evolution of its spiral arms. As this gas moves, it interacts with the gravitational forces of nearby stars, other gas clouds, and dark matter. These interactions cause the gas to clump together in certain regions, while other regions remain more diffuse. This constant motion of gas helps create the intricate patterns we see in Andromeda's spiral arms, where areas of intense star formation are mixed with regions of gas that have yet to collapse into new stars. These areas of gas, where new stars are born, give the galaxy its characteristic swirling shape. Now, imagine how these gas clouds also interact with the older stars in the galaxy. The life cycle of a star, birth, life, and death, is closely tied to the gas around it. When a star dies, especially in a supernova explosion, it throws massive amounts of material back into the surrounding space. This material is rich in heavier elements, elements that are essential for life, like carbon, oxygen, and nitrogen. When a supernova goes off, it scatters these elements into the surrounding gas, enriching the interstellar medium. This newly enriched gas then becomes part of the next generation of stars. The recycling of materials, gas, dust, and elements is a continuous process in Andromeda, ensuring that new stars have the raw materials needed to form. This cyclical process of star death and rebirth, with gas as the common thread, is what keeps the galaxy dynamic. At the heart of this process is the black hole at the center of Andromeda. Though the black hole itself is invisible, its influence is profound. The gravitational pull from the supermassive black hole at the galaxy's center plays a key role in driving the gas inward, shaping the flow of material within Andromeda. As gas clouds move closer to the center, they get caught in the black hole's gravitational field, spiraling inward at incredible speeds. This movement creates a swirling disk of gas and dust around the black hole, generating immense amounts of heat and energy. As this gas is pulled inward, it can create powerful jets and high-energy radiation. While the black hole's gravitational pull helps shape Andromeda's gas flows, it also releases energy that feeds back into the galaxy, influencing star formation and the ongoing cycle of gas movement. One of the most fascinating aspects of Andromeda's gas cycle is its role in regulating the entire galaxy. The flow of gas is not random or chaotic. Instead, it follows a rhythm, a cosmic breathing pattern that has been evolving for billions of years. Gas constantly collapses to form new stars, while old stars die and expel their material back into the interstellar medium. This constant exchange ensures that Andromeda doesn't simply fade into darkness, but remains an active, evolving system. The breathing of gas is what allows Andromeda to remain vibrant, maintaining its stellar population and ensuring that new stars continue to be born. This cycle of gas exchange is what sustains Andromeda's life. Even though gas is invisible to the naked eye, its influence is undeniable. Through the use of radio telescopes, astronomers have mapped the distribution of gas across Andromeda, tracing the flows and movements of gas throughout the galaxy. These maps reveal structures and patterns that are otherwise hidden from view, including the extent of Andromeda's spiral arms and the distribution of gas clouds. These maps help scientists understand how the gas in the galaxy moves and how it contributes to the galaxy's overall structure. By studying the motions of gas, astronomers can also infer the presence of dark matter, which exerts its gravitational pull on a galaxy's gas. The slow, subtle movements of gas provide key clues about the distribution of dark matter in Andromeda, helping scientists refine their understanding of this invisible component of the universe. As we look toward the future, Andromeda's gas will continue to play a central role in its evolution. This gas is not just a passive element. It is actively involved in the formation of new stars, the recycling of elements, and the dynamic flow of material throughout the galaxy. The gas will continue to collapse and form stars, feeding the galaxy's star formation, while older stars will continue to enrich the surrounding gas, adding to the mix of elements that make up future stars and planets. This constant cycle ensures that Andromeda remains an evolving, living galaxy, never static, always in motion. The cycle of gas collapsing into stars, stars dying and enriching the gas, and the galaxy's breathing process are all interconnected. It is a rhythm that has been unfolding for billions of years and will continue long into the future. This cosmic dance between stars, gas, and dust is what keeps Andromeda alive and vibrant. Without this continual process of birth and death, Andromeda would lose its vitality. It is the gas, the raw material of the galaxy, that drives this cycle, ensuring that Andromeda remains a dynamic, ever-changing entity. And so, we see that the galaxy's breath is not just a metaphor, but a real, physical process that shapes its structure, its star formation, and its overall evolution. As Andromeda inhales and exhales its gas, it ensures that new stars continue to be born and that the galaxy remains alive with the energy of creation. This cycle of gas and star formation is what gives Andromeda its ever-evolving nature, allowing it to continue thriving and adapting to the forces that shape it. With each breath, Andromeda grows, changes, and evolves, forever breathing life into the stars and the gas that make up its vast living system. As we step away from the intricate web of gas and stars within Andromeda, we can now turn our attention to something that, for all its grandeur, seems both inevitable and strangely serene: the slow, steady approach of Andromeda toward our own galaxy, the Milky Way. Imagine it, if you can, like a cosmic dance between two immense celestial bodies, each one moving with grace and intent, though the outcome of this dance is far from certain. It's the kind of story that doesn't rush, doesn't demand immediate attention, but unfolds across vast stretches of time. Andromeda is not just a faint smear in our night sky. She is slowly, inexorably moving toward us. But this is no sudden collision, no fiery end or catastrophic explosion. Instead, the galaxies are on a slow, deliberate collision course, one that will take place over billions of years. Yes, billions. A span of time so long that it seems almost impossible for us to truly grasp. Yet it's happening right now, in a way we can't even see. Andromeda, with its trillion stars and swirling dust, is coming toward us at a speed of about 110 kilometers per second. It might sound fast, but in the vastness of space, this is a slow drift, like two dancers gently gliding toward one another, aware of their destiny, but taking their time to meet. To put this into perspective, think about the distance between us. Andromeda is about 2.5 million light years away. That's not a number we can easily wrap our minds around. A light year is the distance light travels in 1 year, around 5.88 trillion miles, or 9.46 trillion kilometers. Now multiply that by 2.5 million. The vastness of that distance is staggering. It's a journey that spans time and space in ways our human senses struggle to comprehend. Yet, even at this great distance, Andromeda is coming toward us, and one day, long after we're gone, the two galaxies will meet. What does it mean for us here on Earth, to know that this grand cosmic event is coming. What does it mean that Andromeda is slowly drifting toward our galaxy? It's a question that carries a certain weight, but one that's wrapped in mystery and wonder. We might imagine that such a collision would be violent, a chaotic event that tears through the cosmos with all the fury of a great battle. But the truth is, galaxies are mostly empty space. The stars within them are so far apart that the likelihood of two stars actually colliding is incredibly small. Instead, the real drama of a galactic collision comes not from star-on-star impacts, but from the way the galaxies themselves reshape each other. As Andromeda drifts toward the Milky Way, their halos of stars, vast, sprawling clouds of stars and dark matter, will first begin to overlap. And as the galaxies pass through each other, their mutual gravity will cause their shapes to distort, sending waves of stars and gas spiraling outward like ripples in a pond. The gas clouds in each galaxy will collide, compressing, igniting waves of star formation. It's an incredible thought. The very collision that might seem destructive, violent even, will actually give birth to new stars, new worlds in the making. The forces of gravity will draw the two galaxies together, and in the end, they will merge. But it won't be a violent crash. It will be a slow, graceful dance, lasting billions of years, before the two galaxies finally merge into one. This process of galactic collision isn't unique to Andromeda and the Milky Way. Galaxies collide all the time in the universe, drawn together by gravity. Some of these collisions are much smaller, involving galaxies that are only a fraction of the size of Andromeda. But even in the case of Andromeda and the Milky Way, their collision won't be the end of everything. In fact, it's the beginning of something entirely new. Imagine the view from Earth, or from whatever future world may exist in this distant future. The night sky, as we know it today, will transform dramatically. Andromeda, no longer a faint smudge in the sky, but a massive, spiraling shape, will grow larger and larger over millions of years. First, it will look like a distant bright, a tiny pinprick of light against the vast canvas of the sky. But over time, it will expand, slowly at first, but then more rapidly as it nears the Milky Way. Its spiral arms will stretch across the sky, and eventually, its core will begin to glow with the light of countless new stars. The night sky will be transformed into a brilliant tapestry of stars and nebulae, each one connected by the invisible threads of gravity as the two galaxies begin their slow embrace. The collision will trigger a profound change in the structure of both galaxies. The stars within Andromeda and the Milky Way will begin to move in strange, unpredictable ways. Some will be flung out into the void, while others will fall into the newly formed core of the merged galaxy. This process of star movement will continue for billions of years, reshaping both galaxies and forging a new identity for the combined system. The core of the newly formed galaxy will likely be a massive elliptical structure, a shape that is very different from the familiar spiral arms of Andromeda and the Milky Way. At the center of this new galaxy, the supermassive black holes of both Andromeda and the Milky Way will eventually collide, merging into a single, even more massive black hole. This black hole, far larger than anything we can imagine, will hold the entire galaxy together, its gravitational pull shaping the paths of stars, gas, and dust across the galaxy. As the black holes spiral toward each other, they will release bursts of energy, gravitational waves that ripple across the universe, detectable by future generations of astronomers. For us, living here on Earth, this might all seem far removed from our everyday lives. We may never witness the collision ourselves, but it is happening nonetheless. And as we look out at the night sky, as we see Andromeda drifting slowly toward us, we can't help but marvel at the vastness of time and space that makes such a slow, deliberate collision possible. The collision of the Milky Way and Andromeda is not something that will happen next week, or next year, or even next million years. It's a cosmic event that will unfold across billions of years, giving us time to contemplate the beauty and the mystery of the universe and our place within it. When we consider the slow approach of Andromeda, we are reminded of the beauty of cosmic time. Time here on Earth moves quickly. Days pass in the blink of an eye. Years slip away without notice. But in the vastness of space, time moves more slowly, at a pace we can scarcely comprehend. The dance between the Milky Way and Andromeda is a slow, steady rhythm that has been unfolding for billions of years and will continue for billions more. In this vast cosmic theater, our lifetimes are but a moment, yet the story we are part of is grand and eternal, written across the stars. And so, the slow approach of Andromeda is a reminder of both the fragility and the endurance of the universe. It tells us that galaxies, like everything in the cosmos, are constantly changing, constantly evolving. And as we gaze up at the night sky, we are witnessing a moment in that long, slow dance. A moment that will one day lead to the merging of two galaxies, the birth of a new cosmic structure, and the continuation of the never-ending cycle of creation in the universe. When we step back and think about it, the vastness of Andromeda, as well as its inevitable collision with the Milky Way, can feel a bit overwhelming. It's hard to wrap our minds around such immense distances and events that unfold on timescales far beyond our lifetimes. But interestingly enough, what gives Andromeda its identity? What transforms it from an abstract concept into something that feels real, tangible, even personal, is the way we as humans have interacted with it. It's a story not just of stars and galaxies, but of our curiosity, our desire to understand, to reach beyond ourselves, and to place our small existence in the context of the cosmos. The story of Andromeda, through human eyes, begins thousands of years ago, long before telescopes or the concept of galaxies even existed. Ancient civilizations knew about the faint blur in the sky. They saw it not as a galaxy, but as part of the constellation Andromeda, a princess chained to a rock in Greek mythology. To the naked eye, it was simply a smudge, barely distinguishable from the stars that surrounded it. Yet, it was there, part of the sky that people looked to for answers, for stories, for a connection to the universe. Fast forward to the early astronomers who began to notice the faint patch of light in the night sky. Persian astronomer Abd Ar-Rahman al-Sufi, in the 10th century, was one of the first to record the presence of this little cloud in his book of fixed stars. Al-Sufi's description was a far cry from our modern understanding of Andromeda, but his observation marked the beginning of humanity's growing awareness of this faint smudge in the night sky. In the centuries that followed, this little cloud would be cataloged, described, and debated, though still understood in rudimentary terms. It wasn't until the early 17th century, with the invention of the telescope, that Andromeda's true nature began to come into focus. One of the earliest telescopic observations of Andromeda came from the German astronomer Simon Marius in 1612. He was one of the first to observe the Andromeda Nebula through a telescope, describing it as a faint cloud-like light, much larger than it appeared to the naked eye. For Marius, it was still a nebula, a cloud of gas within our own galaxy. The idea that Andromeda could be an entirely separate galaxy, far beyond the Milky Way, was still a distant thought. But as telescopes grew more powerful, so did our understanding of the universe. Andromeda, once a mystery, became an object of intense study. Throughout the 18th and 19th centuries, astronomers like William Herschel studied it in detail, noticing its bright core and extended, faint regions. Herschel's observations would lay the groundwork for future discoveries, but it was still unclear whether Andromeda was part of the Milky Way or a separate entity altogether. The breakthrough came in the 1920s with one of the most famous debates in astronomy history, the Great Debate. It was here that two astronomers, Harlow Shapley and Heber Curtis, would argue over the true nature of Andromeda. Shapley, representing the prevailing view of the time, argued that the Milky Way was the entire universe and that Andromeda was simply a nebula within it. Curtis, on the other hand, argued that Andromeda was, in fact, an entirely separate galaxy, a distant island of stars far beyond our own. The debate would be resolved a few years later, thanks to the work of Edwin Hubble. Hubble used the 100-inch Hooker telescope at Mount Wilson Observatory to study variable stars in Andromeda. These stars, known as Cepheid variables, pulse in a predictable way, allowing astronomers to measure their distance. Hubble's work revealed that Andromeda was far too distant to be part of the Milky Way. It was, in fact, a separate galaxy, one of many that dotted the vast expanse of the universe. This was a game-changing discovery. Andromeda, once just a fuzzy patch of light, was now recognized as one of the largest galaxies in our local group, a collection of galaxies that includes the Milky Way. Andromeda's revelation opened the door to a deeper understanding of the universe. It was no longer the universe we had imagined, a small and contained system. The universe was vast, full of galaxies, each one as vast and complex as our own. The realization that Andromeda was a separate galaxy also led to another profound realization. Our universe was expanding. If Andromeda was so far away, and yet still moving toward the Milky Way, it meant that galaxies, in general, were in motion, drifting away or toward each other under the influence of gravity. This discovery laid the groundwork for the understanding of dark energy, the mysterious force that drives the expansion of the universe. It also sparked a new era in astronomy, one where galaxies were no longer seen as fixed, isolated objects, but as dynamic, evolving systems that interacted with one another in a complex, interconnected web. For many of us, the story of Andromeda doesn't stop with the discovery of its true nature. It continues to captivate our imaginations, to draw us in as we look up at the night sky. Even today, Andromeda remains one of the most studied galaxies in the universe. Telescopes like the Hubble Space Telescope have provided us with stunning, high-resolution images of its spiral arms, its bright core, and its swirling clouds of gas and dust. We have mapped its stars, studied its dust lanes, and learned more about its supermassive black hole. We have even studied the light that has traveled across millions of years to reach us, offering us a glimpse of Andromeda as it existed long ago, in a time before humanity itself even existed. For all the scientific breakthroughs and discoveries, Andromeda remains something more than just a subject of study. It's a symbol of our desire to understand the cosmos, to reach beyond ourselves, and to discover our place in the universe. It's a reminder that even in the vastness of space, we are connected to something much greater than ourselves. When we gaze at Andromeda, we are not just looking at a distant galaxy. We are looking at a story, our story, as it unfolds in the stars. In many ways, Andromeda is a mirror that reflects our curiosity, our imagination, and our pursuit of knowledge. It's a reminder that the universe is not just an abstract concept, but something we can touch, something we can explore, something that is inherently a part of who we are. And as we continue to look deeper into Andromeda and the cosmos beyond, we are constantly reminded of the story that began with a faint smudge in the sky, one that continues to unfold with every new discovery. When we think of Andromeda today, it's impossible not to feel a sense of awe, to think that the faint blur in the sky, something we could have easily missed with a casual glance, holds so much mystery, so much history, so much wonder. It's humbling to consider that this galaxy, which we now know to be a swirling, dynamic system of stars and gas, was once just a myth, a cloud in the night sky. Yet, through the lens of human curiosity and perseverance, it has become one of the most iconic and studied objects in the universe. And as we think of the future of Andromeda's slow approach to our own galaxy, we can't help but feel a sense of wonder. What will the sky look like when these two galaxies meet? What new discoveries will emerge as we continue to study the vast, unfolding story of Andromeda? One thing is certain: the story of Andromeda is far from over. It is a story that will continue to unfold long after we are gone. A story that reminds us of the beauty, mystery, and boundless potential of the universe. When we think about galaxies, their size, their scope, it can be hard to conceptualize. We use terms like light years and trillions to describe their scale, but these numbers can often feel detached from any sense of reality. They're abstract, hard to feel. Yet, Andromeda, our nearest galactic neighbor, offers us a chance to understand scale, magnitude, and proportion in a way that few other galaxies can. Its size isn't just staggering, it's deeply humbling. Let's start with the basics. The Andromeda galaxy spans about 220,000 light-years across. To put that into perspective, the Milky Way, our own galaxy, is about 100,000 light-years wide. So, Andromeda is more than twice the size of our galaxy in terms of sheer diameter. But size, in the context of galaxies, isn't just about how far they stretch from one edge to the other. It's also about mass, the number of stars they contain, and how they interact with their surroundings. Andromeda is home to nearly 1 trillion stars. That's a number so large that it almost escapes comprehension. Just imagining the sheer number of stars packed into the arms of Andromeda is enough to make the mind dizzy. But it's not just the stars. Andromeda's mass is estimated to be about 1.5 trillion times the mass of our Sun. This massive collection of stars, gas, dust, and dark matter all comes together to create a gravitational pull so strong that it can stretch across millions of light years, influencing other galaxies and objects in its vicinity. What makes Andromeda particularly fascinating is that its size isn't just confined to its visible disk. While we see the bright, star-filled spiral arms when we look at the galaxy through telescopes, much of its mass lies beyond what we can directly observe. The galaxy's outer halo, an enormous, diffuse region filled with stars and dark matter, extends far beyond the visible disk. This halo can stretch up to 1.5 million light-years from the galaxy's center, far beyond the glowing spiral arms that we associate with Andromeda. The halo of Andromeda is a reservoir of dark matter, an invisible substance that exerts a gravitational pull but doesn't emit light. In fact, it's the presence of dark matter that allows astronomers to measure Andromeda's size so accurately. Without dark matter, the outer regions of the galaxy would move at much slower speeds, and we wouldn't be able to map the full extent of its reach. But because of the way dark matter affects the movement of stars and gas at the galaxy's edges, we can deduce just how vast and far-reaching Andromeda truly is. One of the most striking aspects of Andromeda's size is how it compares to the Milky Way. The two galaxies are often thought of as being similar in structure and size, but in reality, Andromeda is significantly larger. Not only does Andromeda boast more stars, but its gravitational influence is greater. This is evident in the way the two galaxies are interacting. As Andromeda and the Milky Way approach each other, Andromeda's stronger gravitational pull is expected to shape the outcome of their eventual collision. It's likely that Andromeda will come out of this merger as the dominant galaxy, with its mass and size dictating the future of the combined system. When you hear about the size of Andromeda, it's easy to get lost in the numbers. 220,000 light-years wide, 1 trillion stars, and 1.5 trillion times the mass of the Sun. These are all staggering numbers, but they don't necessarily give us a sense of what Andromeda actually feels like. To truly grasp its scale, it's helpful to think about how Andromeda compares to something we're more familiar with, our solar system. Imagine that you could shrink down the entire Andromeda galaxy to the size of a basketball court. In this scale model, our solar system, the space from the Sun out to the furthest planet, Neptune, would be roughly the size of a pea located somewhere near the edge of the court. And Andromeda itself would stretch from one end of the court to the other, with billions of stars scattered across its vast expanse. The sheer scale of the galaxy, even when reduced, is almost unimaginable. Now, let's scale it back up to the real size. Andromeda isn't just a vast collection of stars. It's also a living, breathing system. It has a structure, a shape, and a rhythm. Its spiral arms twist through space, filled with millions of stars, gas, and dust. The galaxy itself is shaped by the gravitational forces of its own mass, as well as the influence of neighboring galaxies. Andromeda's sheer size means that it has a gravitational reach that extends far beyond its visible disk. In fact, the gravitational pull of Andromeda has already started to affect other galaxies in the local group. One of Andromeda's most prominent companions is the small elliptical galaxy M32. This galaxy, though much smaller and fainter than Andromeda, has been slowly pulled toward its larger neighbor. Over the course of billions of years, M32 has been distorted by Andromeda's gravity, its stars spread out in a long, thin stream that wraps around Andromeda's disk. This is a vivid example of how Andromeda's size and mass influence not only its immediate vicinity, but the entire local group of galaxies. Andromeda's size also means that it has a profound effect on the cosmic environment around it. Its gravitational pull affects the movement of stars in the Milky Way, pulling them toward it over billions of years. The collision between Andromeda and the Milky Way, when it occurs, will be a slow, dramatic event, unfolding over millions of years as the galaxies merge. Andromeda's gravity will dominate the merger, causing the Milky Way's stars to spiral into Andromeda's core, reshaping the combined galaxy into something entirely new. But what's even more incredible than Andromeda's sheer size is the way it has evolved over time. Galaxies like Andromeda don't just exist, they grow. And Andromeda has been growing for billions of years, merging with smaller galaxies, pulling in material, and building itself into the giant we see today. As it absorbs smaller galaxies, Andromeda not only gains stars, but also incorporates dark matter and gas, expanding its reach and influence. These mergers and acquisitions will continue to shape the future of Andromeda as it grows even larger, eventually consuming the Milky Way in the distant future. So, when we ask, how big is Andromeda really? The answer is almost impossibly vast. It's not just a matter of measuring its diameter or counting its stars. It's about understanding its place in the universe, a place of power, influence, and evolution. Andromeda's size isn't just about numbers. It's about the forces at play, the movements of galaxies, the dance of stars and gas. And as we look at Andromeda, we realize that its size is not just a measurement, but a story in itself. A story of growth, transformation, and cosmic destiny. For now, we can't fully grasp the immensity of Andromeda, but we can marvel at the fact that we're able to even try. And as we look at it, we're not just observing a distant galaxy. We're looking at a cosmic entity that will play a key role in shaping the future of our own galaxy, the Milky Way. Its size isn't just a curiosity. It's a reminder of the vastness and complexity of the universe itself. Andromeda, though larger and more massive than our own galaxy, is just one part of the cosmic web. Its size is significant, but it's also part of a larger, interconnected system of galaxies, each with its own story, its own place in the vast expanse of the universe. And as we ponder Andromeda's scale, we're reminded that the universe is not static. It's always in motion, always evolving, always growing, and Andromeda is no exception. When we consider how big Andromeda really is, we're not just measuring distance or mass. We're seeing a galaxy in motion, a galaxy that will continue to grow, to evolve, and to shape the universe around it. And in doing so, it reminds us of the vastness of the cosmos and our place within it. Imagine standing on a hilltop on a quiet evening, looking up at the stars, and realizing that those stars are part of something so much greater than we can truly understand. The galaxies we observe, like Andromeda and our own Milky Way, are not fixed in place. They're alive, dynamic, constantly evolving, and eventually they will collide. It sounds like the stuff of science fiction, but this is the reality of the universe. Its galaxies, including our own, are in motion, drifting toward one another, bound by the unyielding force of gravity. In about 4 billion years, Andromeda and the Milky Way will collide in a spectacular cosmic dance, a merger that will reshape both galaxies. But the story of this collision is not a sudden, violent clash of stars. In fact, the collision will be a slow process stretching over billions of years. It will be a gradual coming together, where the galaxies will twist and turn, pulled by each other's gravity, until they eventually merge into one giant, elliptical galaxy. This grand event is often referred to as a galactic merger, but the word merger doesn't quite capture the scale and complexity of what will actually happen. When we imagine two galaxies colliding, we often picture stars crashing into each other, sparks flying, and entire systems being obliterated. But the reality is much more subtle. Galaxies like Andromeda and the Milky Way are mostly empty space. The stars within them are so far apart that even in a galactic collision, the stars themselves won't actually collide. The vast distances between them ensure that they mostly pass by each other unharmed. Instead, the true drama of a galactic merger takes place in the interaction of the gas and dust that fill these galaxies. It's in these regions where stars are born, where new life is created, and where the galactic shape itself is transformed. As the two galaxies approach, their gravitational forces will start to distort each other. The beautiful, spiral arms of both Andromeda and the Milky Way will become stretched and elongated as the galaxies are pulled apart and then back together. The gas clouds within both galaxies will collide, compress, and ignite new waves of star formation. The result will be a spectacular fireworks show of stellar birth. New stars will light up the sky, some burning hot and young, others fading as older stars are formed. The galaxies will no longer have their iconic spiral shapes. Instead, they will coalesce into a much larger, rounder galaxy, often referred to as an elliptical galaxy. But while the shape of the galaxies will change, the process of their transformation will take millions of years. It won't be a dramatic, instant collision, but a slow, graceful merging of stars, gas, and dust, eventually forming a single massive galaxy. This is the natural progression of galaxies in the universe, each one slowly accumulating material, merging with others, and evolving over vast time scales. In the case of Andromeda and the Milky Way, this will be the final chapter of their current forms. What will emerge from this merger is something new, something that will likely be larger and more massive than either of the galaxies that came together to create it. Andromeda, being the larger of the two galaxies, will probably come out of this merger as the dominant force. Its gravitational pull will shape the merged galaxy, determining its final size and structure. But the Milky Way won't go quietly. As the two galaxies merge, the Milky Way stars will contribute to the creation of new star systems, and the remnants of its spiral arms will become part of the new galaxy structure. The fusion of the two galaxies will not just create a new galaxy, but also a new cosmic environment, full of new stars, new systems, and new possibilities. What's particularly interesting about this merger is how it will affect the central black holes of both galaxies. Each galaxy has its own supermassive black hole at its core, a region of intense gravitational pull where nothing, not even light, can escape. As Andromeda and the Milky Way come together, these black holes will eventually spiral toward one another, drawn together by the gravity of the merging galaxies. The black holes will collide, merging into a single, even more massive, supermassive black hole. This event will release an enormous amount of energy in the form of gravitational waves, ripples in space-time that travel across the universe, a sign of the merger of two colossal cosmic objects. But while the black hole merger will be an intense event, it's not likely to have a direct impact on our solar system. Our sun is located far enough away from the galactic center that it will be largely unaffected by the merging black holes. The true effects of the merger will be felt in the gas clouds and the stars closer to the centers of the galaxies. The new supermassive black hole will likely grow even larger as it continues to consume gas and stars, and a newly formed galaxy will have a new core reshaped by the forces of gravity and the merger itself. This galactic merger will not be the end of Andromeda or the Milky Way. Instead, it will be a new beginning, a new chapter in the life of these galaxies, one that will continue for billions of years. After the merger, the resulting galaxy will continue to evolve, forming new stars, gas clouds, and planetary systems. The stars that are left will continue their orbits, and new systems will form around them. Over time, the galaxy will settle into its new shape with a more uniform distribution of stars, gas, and dark matter. It'll be a new kind of galaxy, one shaped by the forces of gravity, time, and cosmic evolution. When we look at Andromeda today, we're seeing a galaxy that's already well on its way to this dramatic merger. The stars that we see today in Andromeda won't be the same stars we see after the collision. Some will have already been consumed by the supermassive black hole at the galaxy's center, while others will have been displaced by the gravitational forces of the merging galaxies. New stars will be born from the gas and dust that fills the space between the stars, and old stars will die, collapsing into black holes or exploding as supernovae. But even as the galaxies merge, the vastness of space will continue to make the process feel slow and subtle. It will take millions of years for the galaxies to fully merge, and even then, the changes will be gradual. The stars will still shine, the gas will still flow, and the cycle of birth and death will continue. The collision won't be an end, but a transformation, one that will leave behind a new galaxy, a new system, and a new chapter in the story of the universe. As we ponder the future of this galactic merger, it's hard not to feel a sense of awe. We're witnessing the dance of two colossal galaxies, each filled with billions of stars, gas clouds, and mysteries, coming together to form something even more magnificent. This event will be one of the most significant in the history of our local group of galaxies, and though it's billions of years away, it's a reminder of the immense scale and timeless beauty of the cosmos. As we've journeyed through the vastness of Andromeda, we've spoken of galactic arms, birth and death cycles of stars, gas clouds, and supermassive black holes. But perhaps the most misunderstood aspect of all these celestial objects, the stars, the gas, the dust, is the vast space that lies between them. The seemingly empty void, the dark expanse that stretches out between the stars. Now, this might sound like a strange thing to focus on when we're talking about the immense scale of galaxies. After all, isn't it the stars, the gas clouds, the glowing nebulae, and the galactic arms that define a galaxy's structure and grandeur? Yes, absolutely. But the truth is that space between stars is just as important as the stars themselves. In fact, it's what gives galaxies their space, their room to breathe, their chance to evolve. This vast emptiness, this empty space, is not truly empty at all. It's full of potential, waiting to be filled. You see, the distance between stars in a galaxy, even in one as densely packed as Andromeda, is enormous. There's so much space between them that stars rarely collide. Despite the billions of stars in any given galaxy, the odds of two stars physically coming into contact with one another during galactic merger or any other cosmic event are incredibly low. So, while we may imagine galaxies as packed with stars that are constantly bumping into each other or getting pulled apart by gravity, in reality, the space between them is so vast that it keeps stars safe, even as galaxies come crashing together. In a galactic merger, like the one we're anticipating between Andromeda and the Milky Way, this space between stars plays a crucial role. As the two galaxies slowly spiral toward each other, their stars will pass by one another at great distances. The gravitational interactions that take place will be immense, but the stars themselves will remain largely untouched. This is one of the most important points to understand about galactic collisions. The stars themselves do not collide in the way that one might imagine. Instead, it's the gas, the dust, and the dark matter, the material between the stars, that will be the real player in the cosmic drama. As the galaxies merge, their interstellar gas clouds will slam into each other, compressing, heating up, and triggering the formation of new stars. This process is incredibly important because it's how new generations of stars are born. Even in the quiet, seemingly empty space between the stars, new stars, planets, and even the building blocks of life are created. The empty void isn't so empty after all. It's a stage for the next round of cosmic creation. The space between stars also has a surprising role when we think about the long-term future of galaxies. In the slow-motion collision between Andromeda and the Milky Way, stars will be nudged, their orbits altered by the gravitational tug of the other galaxy. These shifts, however, won't be catastrophic. In fact, the process will be gentle. For stars like our own Sun, the collision will have little effect. It may move into a new region of the merged galaxy, but it won't collide with another star. It will simply continue its orbit, as it always has. The vast distances between stars ensure that no matter how dramatic the galactic merger might seem, it's the gas clouds and the dust that will feel the brunt of the impact, not the stars themselves. It's almost as if the universe is giving us a little space, a buffer zone between the chaos of galactic collisions. It allows life to exist and evolve, protected by this vast distance. The stars may be the dazzling jewels that light up the night sky, but it's the space between them that holds the true secret to the survival of galaxies, and indeed, life itself. As we look to the future, imagine what it will be like when Andromeda and the Milky Way finally collide. The stars, drifting in their slow paths, will be changed only slightly, moved into new orbits, perhaps even set free into intergalactic space. The true drama, the real beauty of the collision, will unfold in the vast emptiness between them. Where new stars are born, gas clouds swirl, and galaxies evolve. This vast space between the stars also gives us a sense of time, a sense of the immense ages that galaxies live through. When we observe the night sky, we're not just seeing the stars that exist in the present moment. We're looking at a snapshot of the distant past, light that has traveled across immense distances to reach us. The stars we see tonight may no longer exist in the form we see them now. Some may have died in supernova explosions, others may have merged with other stars. The light we're seeing is part of a cosmic history, unfolding over billions of years. In the space between stars, time moves slowly. The distances between them are so vast that any changes, whether through a galactic merger or the birth and death of stars, happen over unimaginable stretches of time. The cosmos operates on a scale that is hard for us to comprehend. But the space between stars allows us to witness these changes, to observe galaxies evolving, stars being born, and the universe continuing its ever-changing dance. As we reflect on the importance of the space between stars, we can't help but feel a sense of awe at the way the universe works. It's a reminder that even in what seems like emptiness, there is immense potential. The stars may be the visible part of the galaxy, but it's the space between them that holds the key to understanding the universe's deeper mysteries. And when we think about the collision between Andromeda and the Milky Way, it's easy to imagine the stars crashing together, a cosmic cataclysm. But in reality, it's not the stars that will cause the most dramatic effects. It's the gas, the dust, and the space in between them that will shape the future of these galaxies, giving birth to new stars, forming new systems, and transforming the galactic structure into something entirely new. This understanding of the space between stars, the vastness of the void, makes us realize how delicate and precious life is. The stars, the planets, and the space between them all exist in a delicate balance. And as galaxies collide and evolve, that balance will be disrupted, giving way to new life, new systems, and new possibilities. So as you think about the vast distances between the stars, remember that in this seemingly empty space lies the potential for everything we know. The space between stars isn't just emptiness. It's the canvas on which the universe paints its greatest masterpieces. Now that we've spoken about the vastness, the stillness between stars, and the quiet force that space exerts on galaxies, it's time to turn our focus to a more captivating, dynamic aspect of the universe: the motion. And not just any motion, but the graceful, mesmerizing dance of galaxies colliding and merging, a cosmic tapestry in motion. Imagine for a moment you're looking up at the night sky, gazing out toward the faint glow of Andromeda, stretching out in its spiral form. You see it as a peaceful, almost serene smear of light. But in truth, Andromeda is not at rest. It's slowly, imperceptibly drifting toward us. Like a pair of dancers circling one another, galaxies too are in constant motion. The merger of Andromeda and the Milky Way, while still billions of years away, is already unfolding in the cosmos, a grand ballet of space and time, gravity and dust, stars and gas. When two galaxies begin to merge, it isn't as though they collide like two solid objects. No, galaxies are not solid. They're made up of mostly empty space, separated by vast distances between stars. So, when the Milky Way and Andromeda come together, it won't be a crash in the way we think of collisions in everyday life. Instead, the galaxies will move toward each other, their stars tracing vast, slow arcs as they are pulled by each other's gravity, their arms stretching and distorting like a beautiful cosmic ribbon. The stars, despite their immense numbers, won't crash directly into one another, but the gas and dust will collide with incredible force. As these interstellar clouds collide, they will compress, heat up, and ignite, sparking the birth of new stars. Some of the stars that we see today, in their familiar orbits, may be cast into new paths, flung outward into the greater galaxy, while new stars take their place in the central regions, their glow lighting up the night in ways we can't yet imagine. These new births are not sudden explosions, but slow, graceful unfolding of new beginnings. The collision will be a process of creation, a rhythm where chaos and order dance together. But that's just one part of the cosmic choreography. Imagine how the gas clouds, some of which are so dense they could form millions of new stars, will be compressed and stirred up in the merging process. Their chaotic movements will create bursts of star formation, lighting up the sky with dazzling new clusters. We're talking about regions of gas so thick, so vibrant with energy that new stars will be born in a magnificent cascading effect. This is how the universe writes new chapters in its story, through the rhythmic collision of stars and gas, through the endless process of death and rebirth. And it's not just the stars that will move. The entire galactic structure will shift. As Andromeda and the Milky Way move closer, their spiral arms will distort, stretching into long tidal tails of stars and gas. These tidal tails are like the long, flowing ribbons of light that trail behind the dancers, the remnants of once beautiful shapes stretched and altered by the force of gravity. Some stars will be swept into these tidal tails, drawn along for a ride, their path forever altered by the galaxy's movements. At the same time, the dark matter that surrounds both galaxies, the invisible yet massive force that holds the galaxies together, will also shift, adding another layer to this cosmic dance. Dark matter doesn't interact with light or matter in the usual way, but its gravitational pull is immense. As the galaxies begin to merge, dark matter will influence the way the stars and gas move, guiding them along their paths, shaping the ultimate outcome of this cosmic performance. Dark matter is like the silent partner in this dance, always present, always influencing, but remaining unseen. And as the galaxies spin toward each other, the supermassive black holes at their centers will also begin their slow spiral dance. These black holes, the most mysterious and powerful objects in the universe, will eventually move toward one another, drawn by the same gravity that is pulling the stars and gas together. This is where things get interesting. Black holes are known for their insatiable appetite for anything that comes too close: matter, light, gas, stars. The merging of two supermassive black holes will be an event of unparalleled magnitude. As they spiral toward each other, they will emit gravitational waves, ripples in the fabric of space and time, spreading out across the universe. This will be one of the most dramatic moments in the entire merger, though it will be far beyond our time to witness. For us, standing here on Earth, the merger is an unimaginable event, a moment in the distant future when the very fabric of the universe will change. The night sky, as we know it, will transform. No longer will we look up and see the familiar spiral of the Milky Way. Instead, we will witness a cosmic collision of epic proportions, a collision that will unfold slowly over billions of years. At first, Andromeda will appear larger and larger in the sky, its spiral arms stretching out toward us. Over time, the two galaxies will slowly begin to blend together, their once distinct structures merging into a single entity. The beauty of this cosmic dance is not in its speed or its violence, but in its slow, rhythmic nature. The stars don't rush toward one another. Instead, they move with purpose, drifting into new positions, tracing out new paths across the sky. The gas clouds, the dust, the dark matter. These will all play their parts in this magnificent story. The merging of two galaxies is not just a cosmic event. It's a process, a story of transformation, of growth, of rebirth. It's a reminder that even in the grandest of events, there is beauty in the details, in the movement, in the slow unfolding of the universe's incredible narrative. As the galaxies merge, the stars will form new patterns in the sky. Some will be flung into new orbits. Others will be absorbed into the dense core of the merged galaxy. New regions of star formation will emerge, lighting up the night with the birth of new stars. For future observers, the sky will be filled with the light of countless new stars, galaxies, and the remnants of old ones. The Milky Way, as we know it, will be gone, replaced by a new, larger elliptical galaxy, a blend of the two. The stars will still shine, but they will shine in a new configuration, a new harmony born from the cosmic dance. And yet, for all the changes that this merger will bring, it's important to remember that the stars themselves will continue their journey, as they always have. The universe doesn't stop for anyone, not even for galaxies colliding. Time will continue its endless march, and life will continue to evolve in the vast, dark spaces between the stars. The dance of galaxies, while dramatic, is just one step in the infinite rhythm of the cosmos. This cosmic tapestry in motion is what makes the universe so awe-inspiring. It's not just the scale of the galaxies, or the size of the stars, or the immense power of black holes that make it grand. It's the movement, the dance, the way everything is always changing, always evolving. The galaxies may collide, the stars may die, and new stars may be born, but the universe will continue its grand dance, its rhythm never faltering. We are all part of it, moving through space and time, experiencing this cosmic performance from our small corner of the universe. As the stars in Andromeda and the Milky Way slowly spin toward one another, drawing closer in the vastness of space, it's hard not to reflect on our place in all of this. We live on a small planet, orbiting a modest star, in a galaxy that is just one of countless billions scattered across the universe. Yet, despite our seemingly insignificant size, we are a part of this grand cosmic story, a story of movement, transformation, and unimaginable scale. So, let's take a moment to zoom out, slow down, and put everything we've explored into perspective. Let's consider our place in this universe. The merger of Andromeda and the Milky Way is inevitable, but it's also a reminder of how dynamic the universe is. It's easy for us, in the day-to-day bustle of life, to forget that the universe is constantly in motion, that galaxies are not static, that time doesn't just tick away in neat, predictable increments. In the span of human history, a mere few thousand years, the idea of galactic collisions seemed inconceivable. The night sky was a permanent fixture, a backdrop to our lives, a constant reminder of the stars. But now, through the lens of modern science, we know that even the sky we look at is in motion, evolving, changing. The universe, in all its immense grandeur, is not only alive but actively shaping itself. In some ways, the story of Andromeda's collision with the Milky Way mirrors the story of the universe itself. Galaxies, stars, and even planets are born, live, and die, each playing a role in the grand design of the cosmos. But just as stars are born from gas and dust, galaxies too form and evolve. They collide, merge, and transform, creating new structures and new possibilities. And we, as inhabitants of one small planet, are part of that vast and ongoing process. We are born from stardust, our bodies composed of the same elements that form the stars, the planets, and everything in the universe. We are not separate from the cosmos, but woven into its fabric, part of the same process of cosmic evolution. Yet, there's something uniquely humbling about understanding that our place in the universe is both fleeting and eternal. On the one hand, the scale of the universe can make us feel incredibly small. We live on a planet that's so tiny in comparison to the immense galaxies and the vast distances between stars. Our lives, too, are short in the context of cosmic time. We live for a few decades, while stars burn for billions of years. And yet, that very sense of smallness is what makes our existence so precious. The fact that we are part of something so vast and ancient is, in itself, a kind of wonder. We are witnesses to a universe that stretches far beyond our comprehension, and yet we are capable of understanding it, of marveling at its beauty and complexity. We are also participants in the ongoing story of the universe. Every time we look up at the night sky, we are not just passive observers of distant stars. We are part of the same cosmic cycle that has been unfolding for billions of years. We, too, are born from stardust, created in the hearts of stars that lived long before our planet came into existence. The atoms in our bodies were once part of those stars, and as the universe evolves, we will continue to participate in its grand transformation. Just as Andromeda and the Milky Way will eventually merge to form a new galaxy, so too will our lives be shaped by the same cosmic forces that shape the stars. We are both small and vast at the same time. In fact, the collision of Andromeda and the Milky Way is a reminder that everything in the universe is connected. The galaxies are drawn toward one another, not just by the forces of gravity, but by the shared fate of all things in the cosmos. They are not isolated entities. They are part of a greater system, part of a cosmic web that stretches across the universe. And in a way, so are we. Our lives may seem isolated, but we are connected to everything around us. The Earth, the stars, the galaxies. We are part of the same system, shaped by the same forces that govern the universe. So, as we reflect on the eventual merging of Andromeda and the Milky Way, it's important to remember that this is just one chapter in the ongoing story of the universe. Galaxies will collide, stars will be born and die, and the universe will continue its eternal dance. But we, too, are a part of that story. Our lives, our actions, our thoughts, they all contribute to the fabric of the cosmos. We may be small in the grand scheme of things, but we are not insignificant. The universe exists not just in space and time, but in us. We are part of it, and it is part of us. As we ponder the cosmic events unfolding in Andromeda, it's easy to get lost in the vastness of it all, to feel like a small, fleeting speck in a universe that's far too big to comprehend. But in the end, that's what makes the universe so beautiful. The fact that we, in our smallness, are capable of understanding it, of contemplating its mysteries, of marveling at its scale. And perhaps that is the greatest gift we can have, to be aware of our place in the cosmos, to understand that we are part of something far greater than ourselves, and to realize that, in the end, we are all connected. So, as the lights of Andromeda continue to drift closer to our own, as galaxies spin and collide, and stars are born and die, remember this. You are part of this magnificent dance. You are part of this endless, ever-evolving story. And no matter how small you may feel in the grand scheme of things, you are essential to the unfolding of the universe. You, just like every star and every galaxy, are a part of the story. A story that has been unfolding for billions of years and will continue long after we're gone. It's a reminder that even in our smallest moments, we are connected to something much bigger, much older, and much more magnificent than we could ever imagine. As you settle deeper into your thoughts, I want you to imagine the gentle glow of Andromeda fading softly into the distance, a symbol of something vast, ancient, and ever-changing. The universe, in all its unimaginable scale, continues its steady pulse, moving in rhythms too slow for us to fully grasp, but comforting in their consistency. Just as the galaxies are on their own journey, so too are we, a part of the same vast tapestry, moving through time, unfolding as part of this cosmic dance. Now, let your mind soften and let go of any lingering thoughts. The stars are still shining up there, and even though they may seem distant, they are always with us, always part of us. With each passing moment, the story of the universe continues, and so does your story. For now, rest and let the comforting idea of connection, of being a part of something so much bigger than yourself, wash over you. As your body relaxes and the room quiets, know that the universe is patient, steady, and ever-present. The light of Andromeda, the stars in the sky, the galaxies on their way, they're all waiting, moving forward at their own pace, just as you will. Allow that rhythm to calm your mind, letting you drift peacefully into sleep, knowing that the beauty and mystery of the universe is not just out there, but within you as well. Take a deep breath, relax into the soft hum of the world around you, and let your thoughts gently fade into dreams. The universe will continue to unfold, but for now, rest easy. You're part of this grand story and always will be.